So this is test 2 for last year lah, 3823 question lah. Okay, this question is related to attribute control chart. Okay, quality of t-shirt was recorded from a randomly selected bundle each day for 20 days. The number of t-shirt inspected, number of non-conforming and number of non-conformities are given in table 1. Okay, dalam soalan ni dua-dua diberi. Non-conforming pun diberi, non-conformities pun diberi. The t-shirt manufacturer is facing quality problem, okay, such as unclear print, missing button, poor stitching and tear. If any of such non-conformities found, the t-shirt will be classified as non-conforming. Okay, the company plans to implement a control chart to monitor process variability. Okay, so it's given for 20 days. So apa yang kita lihat di sini ada 20 hari ya. 1 di sini mulanya sampai 10. The same table continue 11 to 20. Okay, so 20 hari lah. So these are the result of inspection of 20 days. Number of t-shirt inspected, okay, 50, 50, 75, 75 and so on. So meaning that n is variables. Okay, in this case n is variable. N is not constant. Okay, sometimes the number of t-shirt in bundle is 50. Sometimes it's 75. So basically the question has been simplified lah. Ada dua saja walaupun variable kan. Ada dua choice, meaning that you have to calculate for 2 sizes of sample. Okay, non-conforming is given here 10, 3, 10 and so on. Non-conformities are also given. Okay, 14, 20 and so on. Total number of t-shirt inspected is 1250. This is basically the summation of this t-shirt. Summation of all these, okay, is given here 1250. So the question says construct a suitable control chart to monitor the daily defective non-conforming t-shirt. So rasanya control chart apa yang perlu digunakan? What type of chart? Anyone, please? Or you can respond to the chat board. What type of chart suitable to answer question list number 1? U-chart. U-chart, is it correct? U-chart, this is non-conforming. The question is asking daily defective or non-conforming. Non-conforming chart, okay, we have NP chart ataupun P chart. Only 2 choice. Okay, we know that P chart and P chart, this is boleh pakai tak variable kalau NP chart? Kalau P chart for sure boleh. Kalau N constant okay, N variable pun okay. Okay, and variable both are okay for P chart. Okay, and P chart, N is constant. Okay, so it is not for U chart. This soalan is not for U chart and also not for C chart. Okay, because it's asking daily defective, okay, which is non-conforming. non-conforming chart is either P chart or NP chart. Okay, is it okay, that one? Okay, so let's see the solution of it. Okay, I have shared also with you, but please don't see the solution first lah. You try yourself dulu. Jangan tengok solution terus. Jadi sebab apa? You tak tahu kat mana, tak faham. Okay, let me save our time. Okay, we can have this. Okay, let me share with you. This is the solution. Okay. Okay, nampak solution ke belum? Nampak tak?
Nampak, Doktor.
Nampak sample answer. Is it correct? Yeah, nampak, right? Okay, so this is sample answer. Already share with you, but let me explain. Okay, so jadi chart apa yang nak pakai? Chart yang sesuai adalah soalan tadi tanya number of non-conforming kan, so it is will be NP chart lah, NP chart. Okay, so jadi N is given. Okay, so now NP also given. Okay, this is number of non-conforming. P is the ratio where you have to calculate lah, 10 over 50, 3 over 50. So you get all this number lah. Okay, and upper control limit and lower control limit. So nampak banyak, tapi actually you just only to calculate for N equal to 50, and another one is N for 75. For the control chart, for the control limit. Okay, so if you see here, control limit here, if N is 50, this is the control limit. If N is 75, this is the upper control limit. Okay, so in the chart, okay, you calculate upper control limit. Lower control limit for this chart is not significant. Okay, because it's negative, so we just make it 0. Okay, make it 0. So, okay, so you prepare for P chart. Okay, P chart is the ratio. P chart is ratio. Okay, so I think this one. Okay, there are a few ways of answering lah. There are students answering using average. Also, you can use also average and average. Okay, if you use an average also can, but only one control limits lah. Okay, so let's see the question again. Okay, the question was asking. Okay, question tadi. Okay, the question. Okay, the question kat sini tanya, construct a suitable control chart to monitor daily defective non-conforming. Okay, daily. So you can answer as NP or NP memang tak boleh lah kan? NP tak boleh, so you have to answer using P chart lah. Okay, P chart. Okay, P chart because it is variable sample size. Okay, the way you answer can calculate individual control limit, which is N for 75 and N for 50. Ataupun you take all the N and get the average. Okay, get the averages. So the detail is already shown, okay, in the solution. I think solution you can go through on your own lah. Unless you have question, you can ask me lah. Okay, this solution. Yeah. You kena sebenarnya dua je UCL ni. Nampak yang banyak ni. This is N50 kan? Okay, this is UCL. When is N is 75, this is N75. When the N is 50, again, use the same number. Sekali je kiranya. Nampak tak? So, kena sesuaikan lah. So, no need to recalculate because you already calculated. So, back to your question, nak kena tunjuk kiraan. Yes, tunjuk kiraan untuk N50 and N75. Itu saja. 2 kali. 2 times kiraan. And just repeat aja number ni. Faham eh? Okay. So this is the formula that you use. Okay. This is the formula. This formula which is P bar plus 3 square root of P bar 1 minus P bar. Okay, formula will be provided lah, tapi you can understand lah how to use the soalan. So the only difference now is this N. Okay, this N. Okay, either use 50 or use 75. Okay, this N. Kalau you take the average, so the N will be an average lah. Okay, instead of N50 or N75. So this, in this case, okay, 50 is used. Okay. So just show sample of calculation. No need to show all calculation lah, but they're repeating. Okay, the case that okay, I think this student, the other question, solution is using N average. How you get an average? Summation of N 1250 divided by 20 subgroup. Okay, got 62.5. So this is N average is used in the formula. Okay. So I think you can go through lah. Yang lain tu is standard lah. Okay, standard. Okay, any question on this? Okay, I move to soalan yang kedua. Okay, soalan kedua, second question is okay, second question. Construct a suitable chart to monitor number of defects, okay, which is non-conforming per unit t-shirt. Compare with the chart plotted in question 1 and give your comment. So what chart? Agak-agak now. Number of defect. What chart? Non-conformities per unit t-shirt. Any suggestion? Please respond to chat box or on your mic. Okay, what chart? U chart. Okay, Ardini. Okay, that's correct. Okay, number of defect, non-conformities. Okay, non-conformities per unit. So we know that non-conformity per unit is U equal to C divided by N. Okay, C divided by N. So where is the C? Okay. So you can get this is non-conformities. So this is actually macam C lah. Okay, this is like a C. But we cannot use C chart. We cannot use C chart because kalau C chart dia punya inspected unit must be equal to 1. Okay, so the chart we should use is U chart. Okay, U chart. Number of conformities is Okay, 20. Okay, start from the number 1, 14, 12, 20, and so on. So this is actually the C. So because of the dia punya sample size is not n is not equal to inspected unit of 1, okay, we cannot use C chart, so we use U chart. Okay, so what is U here? In this case, sample number 1, U will be 14 divided by 50. Okay, second one, 12 divided by 50. Okay, third one, 20 divided by 75. Okay, so this question is related to this one. Okay, using this data, okay, divide by this. Divide by this, and then we can know that how many non-conformities per unit. Okay? Conformities per unit. Okay, so let's see the solution. Okay, the solution. Okay, the solution is, okay, you need to go through on your own after this. I'm just showing you just general. Okay, so this is the solution where we have, okay, we have this value n, you have C, you have U. C is given, U is what you need to calculate, and you need to calculate UCL and LCL. Again, okay, this one you require calculation of UCL for 50 and UCL for 75. You see here, the number here, this is for 75, number here is for n equal to 50. Okay, so the repeating, the only thing that you need to calculate individually is this one. Okay, this one, which is 14 divided by 50. Okay, this is what you get. This divided by 50. This is what you get. This is by 75. Okay, this is what you get. Okay, so after that, the rest is the same. Okay, of course, you need to get the central line. Central line, we know that this central line, U. Okay, U bar is basically summation of all the C divided by summation of n. Okay, this is what you get. And you need to get, as usual, upper control limit and lower control limit. Okay, so okay, this this student, he answered using P chart, which is no, I think this is P chart for the earlier one, but this is the one that U chart number 2. Okay, this one. Okay, so we use this formula. Okay, U bar plus 3 square root of U bar divided by n. Okay, again, you also can use this n average. If you do not want to use individual n, which is n equal to 50, okay, or n of 75, okay, you can get n average. Okay, n average. N average only meaning that you calculate once. So either way is okay. Okay, if you are using n average, okay, if you are using this n average here, okay, you need to find what is the n average? Okay, summation of n, summation of n divided by 20 lah. Okay, so it turned out to be 62.5. This is n average. Okay, this is n average. Okay, and then what you plot? You plot the value of u. Okay, you plot the value of u inside the chart, and then the value 1 is outside. Okay, so this number outside. Okay, so now a point is outside control limit. Okay, so in the P chart, because this question asking to compare P chart in question 1, all points are in control, but on U chart, point number 8 is outside. Okay, that is comparison. If the question asks to revise, you need to remove this point and recalculate again the control limits. But in this soalan tak ada tanya revise, they just keep asking you to compare it. So if you are required to revise, then you need to revise. Okay, any question? Is it okay? Yeah, okay. Yes, correct. Yes, 19, correct. 19. So the revised control limit will be used for future monitoring. Maknanya the next, when you run the process, continue the process, assuming when you remove, you must assume that point is due to assignable cost. Okay, you assume assignable cost, meaning that that cost can be identified and can be corrected lah. If you found this is out, but you cannot find the root cause, you cannot remove simply like that. In practice lah, in practice, before you remove this point, you must assume that assignable cost has been identified. Maksudnya, what is the cost of this problem, of this product to be outside control limit, because it's so unstable. So before you remove, for the purpose of academics lah, you say assume assignable cost. Okay, assume assignable cost, and the process can be improved. Okay, so process is corrected. Okay, proses tu dah dibaiki lah. Process corrected, and you can discard. So what you do is you discard, you buang lah, buang that point. Okay, you buang this point, and then you recalculate balik lah. So maknanya kalau this point reading dia berapa, saya tak pasti 0.5 something lah, 0.6 So you remove lah dia daripada sini. This is 336 336. Okay, this number, the total of C minus that. Okay, can somebody read for me what is that number? This number? Number C number kat sini. Number 8, number 8. What was the C? Okay, number 8. Allah, tak tulis pula. Okay, this is number 1, number 2, number 3, number 4, 5, 6, 7, 8. Okay, 28. Okay, the C was 28. So you just remove that 28. Okay. So minus 28. Okay, divide by. Okay, you have here 1250. 1250. Okay, 1250. 1250. Okay, summation of n, summation of n. Minus, okay, berapa number tadi? dalam sampel nombor 8 tadi? Berapa? 50 ke 75? Can somebody help me?
50 tu.
Berapa? 50 ya? Okay, 50. So, and then you get a new U lah kat sini. Okay, new U lah. Untuk plot kepada chart nanti. And then, control limit pun kena kira lah. Control limit sebab now your U dah berubah U. Dalam di sini dia pakai U node. U node sini sebenarnya U bar new lah. U bar yang telah di-revise. Yeah, different people use different symbol lah, but you can say this is U bar revised lah. U bar new. Okay, what is U bar new? So this new value kat sini lah. New value yang kira ni. Of this, masuk situ. Tu campur 3, U bar U node ni, U node yang baru lah. So, and then an average ini akan berubah lah sebab dia dah dapat U baru kan. So itu saja for the revision. And then because of this, sebenarnya you punya control limit jadi semakin sempit sebenarnya. Okay, kalau originally this is your control limit, after you revise, okay, you may have tendency to have control limit berendah sikit, dan yang ini pun turun sikit. Okay, kalau asalnya dia berada di sini, so now dia step down sikit lah, turun. Okay, ini pun turun sikit. So bermaknanya there is improvement in the process in terms of producing non-conforming products. Okay, any more question?
Doktor nak tanya.
Yeah.
So kita punya like apa yang kita dah sampaikan. What if first kita revise tu, kita dah buang, and then tiba-tiba ada new point that above the upper control limit, like sebelum ni dia tak, but sebabkan dia dah sempit, so ada one point that suddenly above control limit, so kita kena revise lagi sekali tu.
You mean the point is from the previous process or for the new process?
The previous process. So since like for example, first process the only that above control limit like 28, but after revise, for example, after revise we get UCL 35, but and then the point before this is 27, already above the limit. So before this dia tak naik atau ni.
Ya, saya faham. Okay, maksudnya bila kita dapat new control limit, and then the data yang kita collect previously happen to be outside the new control limit, kan? So dia sebenarnya kita plot revise control limit untuk new data. We don't use old data anymore. Faham? We don't use old data to plot. We use the control limit. Dalam case revision, we remove the old data yang outside control limit. The purpose of removing is to get revised control chart. The revised control chart is to be used for to monitor the next process. Okay, dia agak macam terbalik sikit lah. Before that, you collect all the data. And then you produce control limit, control chart. But now the revised control chart, okay, this macam revise ni kan. Where is the data? There is no data yet. You are monitoring this for monitoring future process. Not for plotting the existing data. Okay, some people even in the implementation they may overlook this, but mungkin dia tak berapa clear dari segi konsep for monitoring future process. So meaning that you already have control limits for the next process. So let's say you start, okay, I just put a line kat sini just to guide. Sebenarnya ini pun kosong kan, tapi saya tak nak overlap masa tu. Saya katakan, okay, the next day you continue the process. The next point you get is number 21 kat sini. Okay, number 22. Sebab tadi berhenti 20 kan? This is the new data. And then you get the data, you plot. Okay, you get it here. The 21 pun you get it here. And then number 23. And then suddenly 23 kena kat sini. Okay. Sekarang ni you are collecting new data. Okay, this line was coming from the revise. Okay, this line is revised. From the revise, okay, revise control chart, which is coming from using the previous data. Okay, previous data. But this line, the revise control chart, is for the purpose of monitoring the future process. But you need to continue the process. So whenever the point that you are producing, you keep monitoring whether it is within control limit or not, or it is outside control limit, based on revised control limit. Okay, so we do not have the control limit using this data, not yet. Okay, this data, katakan happen to be at a few point outside, you revise again. This is revised for the new revision pula. Boleh faham ke?
Revise for new revision, what?
Okay, so okay, macam ni. Sekarang ni katakan you plotting dan dapati ada data yang baru ni. This is new data, not old data. Tadi you referring to the old data kan? You kata kenapa? What happened if ada lagi? Contohnya bila revise sebelum ini, yang ini tak ada, katakan contohnya. Katakan yang ini sebelum ni dalam kan? Sekarang ni tiba-tiba dia ada di luar kan? I think that what you meant, right?
Betul.
Okay. So ini kita dah tak kisah dah. We don't care the old data. Sebab this new line yang biru ni, it is for the new data. Faham ke? Data ini tak guna dah. Sebab dia dah dapat control limit dan kita dah revise. Data yang diplot is a new data. Okay, new data. Okay, new data. So old data no longer used. Okay, we plot new data. Okay, so now let's say you dah plot new data and it happened to be that dia terkeluar daripada revised control limit. Okay. Let's say terkeluar. Okay. So bila terkeluar ni sebenarnya kita dah boleh stop proses. Okay. Kita boleh stop, kita tahu it's unstable. So what we need to do, we have to identify the assignable cause, okay, make a correction to the process, and after kita dah remove ni, we have to revise again. Kalau kita nak buat buat proper revision, kita kena cukupkan data 20 dululah. Okay, run it until you get 20. Okay. Kalau you nak revisekan based on kat sini pun dah boleh, tapi you kena join dengan data sebelum ni. Tapi it is not reflective the new process lah, sebab you guna data lama kan. Tapi it is recommended you complete sampai 20, ini 21, completekan sampai 40 lah. Okay, sampai 40 and then baru buat revision. Unless process is very serious, you jangan revise lagi. Okay, kalau proses very serious, you stop the process, make correction, ataupun whenever you adjust the process, you kena adjust the control limit juga. Itu yang memerlukan revision. Tapi kalau you don't do any adjustment, katakan you know that this process is out, okay, the process is out, and then you run, it come back to the normal process balik. Okay. So jadi itu mungkin it's not systematic lah. Maknanya it is not something yang continuing the problem embedded to the process. So mungkin it is just coming and then it is coming back to normal. Tapi kalau di kat luar, the continuing kat luar, okay, mungkin saya erase kat sini nampak crowded. Okay, let's say this point pun keluar, and then you continue the process. Proses tu masih keluar lagi. Okay, masih keluar lagi. So definitely the process has to be stopped. It has to be stopped. Sebab apa? They're getting worse. They're getting worse. So you don't want to produce defect products. Don't need to wait until 40. No need. Okay. So what you do, make the repair to the process. Repair the process. Okay. And then continue with the production. Okay, sampai 20. Okay, kalau dapati masih tak stable, you still need to revise the control limit. Okay, but remember, the process must be corrected. Okay, you must do something to the process to improve it. Tak boleh buang saja, tak boleh buang point saja. You must do correction to the process. Is it okay or not? So the idea is macam ni. Revision can happen many times. I mean, let's say this is the original. Okay, after your revision, the punya center tu mungkin turun, and then ni pun turun juga sebab ada improvement lah. Okay, after apa ni, you say that the process still not stable, you revise balik. Okay, you revise balik, so it's getting better. So now the quality is improving until there is no more improvement can be done. Maknanya kalau no more improvement, you tak buat revision lah, continue je lah. Okay, you see that originally this range is big lah. Okay, dia punya tolerance very big lah. I mean the range of dalam case ni adalah non-conforming unit tadi kan. Okay, so they keep reducing. Okay, sebab every time we get a point outside the control limit, they show that the process is not stable. So mungkin kat sini you get a new point which is somewhere here. Okay, if we refer to the old control limit, okay, this is old control limit, we refer to this one. Kalau pakai yang lama, dia macam dalam lagi. Okay, because of we already revised, okay, dia baru keluar. So we need to look at this point, what cost dia berada di luar. Okay, after we identify the cost kat sini, the root cost can be mungkin broken tools ataupun some component in the machine has loosened, for example. Okay, ataupun wrong material, ununiform material. Jadi kalau identify, kita remove. Okay, kita remove. We have to revise again this chart. After we revise this chart, we get a better one. Okay, so basically control chart is used for continuous improvement. We don't stop only one revision unless they are stable. So normally at the beginning it is unstable. Okay, unstable meaning that there will be out of control limit due to assignable cost. Okay, so as we move on, the process becomes stable. When the process is stable, the control limit of that stable process is used to monitor the future monitoring. Okay, we use the control limit for future monitoring. I hope that clear. Alright, can I move on to the next question?
Can.
Right. Ada soalan lagi ya?
Wah, tak ada, Doktor.
Okay, saya move on to the next question. Okay, next question tanya, assume that or any of non-conformity observed exceed the upper control limit due to assignable cost and can be rectified. Revise control chart. Ni saya dah terang tadi lah. Dia minta revise. Buang tadi lah. Dia terang tadi. Alright, question number 2. Expression number 2 ni tak masuk test 2 for your case lah. But anyway, you can prepare this for your final lah. Okay. So I'm not going to discuss now for that because that is not part of the scope. Okay, this one is reliability, also not in your test number 2, but you can prepare for the final. We have not discussed on this is tajuk reliability, reliability. Okay, we will discuss it next week. Once at the class, we will discuss on that reliability lah. Okay, let me move on to other questions. Question. Okay, test 2. 611. I think this is the one. So I'm taking this question. Saya tak pasti which one. I think this is the one ago. This is February 2021. Okay, this one kita tak cover untuk test number 2, but anyway, good for your prepare for your final. Okay, this also X bar R tak cover dalam test 2, kita dah ada dalam test 1 hari tu. Ini pun dah cover test 1. Okay, this one soalan ini lebih kurang soalan tadi. But the question is, nampak ya? Yang saya tunjuk sekarang ni. Hello?
Tak nampak.
Nampak Itu berkaitan dengan tiles. Okay, tile production. Patternnya sama saja. Number of tile, number of non-conforming, number of non-conformities. So saya rasa you can go through what yourself lah. Sebab saya dah terang tadi Try yourself. So, lebih kurang soalan tu. Okay. Mungkin beza kat sini lah. The company would like to save inspection and decided to reduce the daily sample to 30. They ask you comment on how this may affect sensitivity. Okay. So the company used n equal to 30. Currently, how many? Currently, the sample was 75 and 60. Okay. So currently n was 75 and 60. So the question asks, what happens if the company decide to use n equal to 30? Apa akan berlaku? Any idea? Okay, from the formula, okay, is it referring to any control chart or not? It's not. Company would like to save cost, decide to reduce daily sample. Okay, dia tak sebut which chart. Okay, whatever chart it is. Okay, when you reduce the n, okay, what will happen to the control limit? What will happen to control limit? Ini ada kaitan dengan control limit. What will happen to control limit? You cuba tengok tadi n equal to 75. Di mana control limitnya? N 75 compared to n 50, yang mana lebih besar? Control limit? Can anyone respond to me? Which one is bigger, N75 or N50 control limit? Okay, N50. Okay, N50 has bigger control limit. So when you go to N30, maknanya control limit will become bigger. Okay, so basically kita boleh dapat tahu dekat situ dah. So smaller sample size will increase the control. Okay. So kalau kita tengok tadi kita tengok dalam solution tadi. Okay. So in the calculation kita boleh nampak konsep yang sama lah. Okay, if you see here, okay, you have upper control limit. Okay, upper control for N50. Okay, N50, this control limit. 0.45. When N is increasing to 75, this value reduce. Okay, this value reduce from 4.49 reduce to 0.45. Maknanya smaller lah. Okay, so jadi kalau kita make it 30, so this value will increase. Okay, will increase. So bigger control limit. So that question is testing understanding lah. Right. Okay. Number 3.2 ni related to dim read. Okay, dim read control chart. Okay, dim read control chart 10.3.1 dim read rating system, standard non-conforming per unit for critical, major and minor is given here. Sample size is 50, prepare control chart. And then after that is asked, what happens if you get 5 critical, 25 major and 50 minor? Non-conforming, determine the status of this process. Okay, maka imo saja. Okay, so this one, okay, you have that solution. That solution is I think this is the solution. Tak pasti pula betul tak ni solution dia. Soalan berapa tadi Chart. Ni, this is the one. I think this is the set B kot sebab ada dua set, jadi dia dah keliru sekarang ni. You kena tengoklah set 1 atau set B. But anyway, the solution for 3.2 ada kat sini Tadi 3.1 apa tadi? Okay. Solution for 3.2 ada kat sini. This is I think set B lah, set B soalan set B. Okay, let me check the set B set B, set 2, sorry, set 2. Okay, set 2. tadi kan, 3.2. Yes. This is a soalannya. Set 2, set 2. Soalan set 2. Okay. So this is the weightage system. This is for critical. Okay. Critical higher weightage. Okay. And then you have major and you have minor. Okay. So the U value already given. This is U for critical. U for major, U for minor is given. Okay, so I think straightforward lah, just use the formula saja. Okay. Okay, so that's 3.2. Okay, soalan 4. Soalan 4 pun belum tak cover lah test 2 sebab ini adalah lebih pada acceptance sampling. Soalan 4 acceptance sampling. Right, I think there is one question covering on EWMA. Okay. WMA. This one. Okay, ini reliability kita belum tahu, ini tak masuk. Can anyone help me dalam soalan yang banyak-banyak saya bagi tu? Which part is yang ada sampel soalan mana yang ada EWMA? Yang mana satu? Boleh siapa-siapa bantu saya cari? Okay, this part is not covered in your course because there are another course including productivity. This is not included in your syllabus lah, productivity. But the part of quality system, okay, ni tak masuk lah. Okay, yang masuknya bahagian ini. Bahagian ini relevant, but this already test on test 1 on this part. Ini. Okay, this soalan. This soalan ini related to EWMA. Okay, EWMA. Soalan 4, okay, berkaitan dengan X bar. Ini soalan ini berkaitan dengan demerit. Okay, this is demerit chart. Okay, soalan 5. This is life history. This is reliability. Reliability. Reliability tak masuk test 2, but you need to prepare for final lah, reliability. Reliability. Ini acceptance sampling. Okay, this will be final, not for the test number 2. Alright, so yang relevant kat sini di sinilah. Okay, exponentially weighted moving average. Okay, exponentially weighted moving average was designed using alpha equal to 0.1, L equal to 0.7, target value 10.5, standard deviation equal to 1 at steady state. The value for upper control limit and lower control limit are already given. New observation, okay, already given here. Okay, jadi soalan ini dah simplified lah. Okay. Comment on the status of the current process. Provide justification why EWMA control chart is sometimes preferable than other control chart for process monitoring. Okay, so 3.2. Okay, let me see. I think we have solution somewhere. 3.2. 3.2. Okay, formula yang sini biasa kita sediakanlah formula ni. Okay, solution is not here. Okay, 3.2. 3.2, let me find the solution. 3.2. Yeah, 3.2. Okay, 3.2. Oh, tak ada kat sini pula. Three point two. Okay. Alright. Dapat tengok ke? Hello? 3.2. Okay, so this is solution for 3.2 lah. Okay. So you have this. I think the same soalan ataupun sebab ada dua version. Sometimes mungkin nampak betul ke 10.3.1 tadi? Can somebody confirm with me? You have U 0.5, MA 3.4. Betul kan jadi?
Betul, Doktor.
Betul lah? Okay, so basically this is the solution lah. Okay, so you have to get the D, which is, this is the weightage lah. Weightage, and this one is given. Okay, this is given. This is given. And 50 ni guna kat sini lah. And to get the control limit, this is the formula. D bar plus 3 mu sigma u lah. Okay. And then dapat control limit, and then ada data diberi tadi kan, ada 3 data. So that data tu kita check lah. Dapat jadi dia. And it found out that the value was outside. Okay ya, saya rasa saya berhenti situ dulu. Okay, so I hope that you can go through this, and if there is a need, let me know. Maybe we can have another session before the test lah. Mungkin dari Ahad, kalau perlu you maklum pada saya lah, if you have any request for clarify if there is any question. Okay, anything else? Nak tanya?
Doktor, satu.
Ya. Okay, silakan. Hello, siapa tanya tadi? Tak dengar lah. Boleh ulang balik? Ada 3 soalan. Ada chart macam mana? Dia ada problem dan ada requesting you to solve problem, and ada soalan berkaitan dengan interpret lah soal jawapan tu, explain, brief explanation lah maksudnya. Okay, so basically test nombor 2 ni fokus pada control chart sajalah. Okay, kita ada QSUM, EWMA. Okay, saya tak tunjuk DNOM. DNOM tu ada dalam tugasan, so you kena review dalam tugasan lah. P and PCU demerit tu saya terang tadi lah. Okay, reviewkan juga QSUM, EWMA and DNOM control chart. Okay, saya rasa dah 4 suku ni. Kalau tak ada soalan boleh, kita boleh berhenti sini lah. Unless you have soalan, bila soalan I can stay online for another 10 minutes.
Doktor, mostly
Yeah.
untuk satu soalan berapa minit dibagi?
Okay, saya gunakan masa kelas, so jadi saya estimate dalam setengah jam lah satu soalan. Okay, sebab our slot is, we have 2 hours punya slot kan. 2 hours slot, so 3 soalan maknanya 30 minit, jadi sejam setengah lah. So soalan will be released one by one, so you need to answer one and upload one. So one by one punya ni lah.
Okey, betul.
Yeah. Right, any more question? Kalau tak, ya.
No.
Okay, kalau tak ada itu sajalah. So please make your preparation lah for the test. So anything that you communicate through Telegram lah. Okay. Assalamualaikum warahmatullahi wabarakatuh.